How was homework assignment? Seemed too easy.
Yeah.
Oh, I'm glad.
Like I was questioning myself a lot.
So it seemed too easy to process a let expression that that extended an environment. You start seeing how we're actually solving a more difficult problem because we're getting better. is that the punchline? All right. So what were we supposed to do? We were supposed to write the thing for let in var expression. All right. So let's go ahead and do the var expression first. All right. We're already parsing for this guy, right? So when we see a var expression, we should boil down to the corresponding value in the environment, right? Or a false, I guess, if it wasn't in the environment. Actually, technically, we probably should do the let expression first because we can't really test the var expression without a let expression, right? Because we don't have new things in our environment. All right, so let's do a let expression first. So our let expression gives us a single variable value pair. So that allows us to extend our environment. So that's what we should do when we see a let expression. So it's going to be a let exp. So let's go into here. So EQV, car, parsed expression, let exp like that. Is that how we wrote it? All right. And so if we have that guy, and if we want to go ahead and here, let me just close this out. I'll just throw a false in there or something like that for right now. Actually, it's a lowercase f, I think. I'm just getting it to go past that for a second. So I want to define my function here to be a little different. So we're going to make it a let. So we're going to, if we go in here, for our lets, we're going to say let identifier equals expression. So are we saying, how did we write this guy? Did we say let A 5 and then in the body A? Is that how we wrote that guy? Then we parse the expression, look at parse P. So here's our let expression. Here's our A. It's equal to the const expression 5. And then here is the body of that guy. So does that look right? So this is the variable environment. Well, this is the things we should expand in the variable environment. So this is a to list. The variable name and the value of that variable name. So this is the guy we need to use to expand our environment, right? And then we need to apply that guy with the newly expanded environment inside that body. Okay, so we know what this thing looks like. So if we look up at Extendenv, which I gave you as a starting point. So we started off with an empty env. Extendenv takes a var, a val, and a current environment, and it gives us an extended environment, right? So let's go and start with that part. All right, so we know if we're in here, if we're in a let expression, I'm looking at something that looks like this. So the car of it is the let expression. So now I know I'm going to be applying my expression for this guy. So this is the car. This is the car of the cooter. This is the car of the cooter. Correct? So car of the cooter is the body of this let. So I'm going to be calling apply expression on the car of the cooter parsed expression. All right, so that will give me this piece right here, right? That's the expression I'm going to be evaluating. But I want to evaluate it in a new environment. The environment I'm going to evaluate this guy in is the environment extended by, this is the car of the cooter and the car of that. So let's just put this on a couple of separate lines. So apply expression on that expression along with extend env. And Extendenv takes a variable name, a value, and a current environment, right? So what's my variable name? My variable name is going to be,
I think it takes in the environment.
takes the environment first. Can I just look at it? Do you know how much scrolling you just cost me?
At least 4 scrolls.
Apology not accepted. I didn't apologize. Apologize! Not accepted. What was I doing? All right, Extendenv. So I need to give it the variable name first. That's how I need to get this A part, right? So this guy is the car of the cooter. So I need the car of that. Correct? So it's the car of the cooter will get me this A. That's the CAADR of parsed expression. So that'll get me that A. Then I need the value of that guy. So that's this guy right here, right? But he's not the value. The value of that guy is the apply expression of that guy in my current environment. Make sense? Follow me here? All right. So this guy will be, where am I? Up here? So the value of this guy will be apply expression of this dude, which is the, this is the car of the cooter. This is the car of the cooter of that guy. So CADAR. C, car of the cooter, CADADR. Let's just do it as 2 separate cars of the cooters. Because actually, I'm not sure if that other one works. So we're going to say the car of the cooter of the car of the cooter of parsed expression. All right, so that is the, I'm actually going to kick this down a line just to keep it. So that is the expression we are going to be applying, and we're going to be applying it in our current environment, right? Which should give me, in this case, just the value 5. But just in case that was something else, we want to apply that expression in that environment. All right, so I'm going to be extending an environment with this variable name, and then the result of apply expression on that guy. So that will be my extended environment. Now, so that's my brand new environment. In that brand new environment, we are then applying the expression of this dude, which is this guy right here. So that's the expression we are applying in that new environment. Make sense? All right, so that should be how to process a let expression, extend an environment, and apply the expression in the body of the let. All right, so while we're at it, let's go ahead and write the var expression. EQV car parsed expression. Now, let's just stop here for a second. Now, those of you who thought this was easier, did you pretty much write it something like this? Do you recognize how much harder that is, what we just wrote there, than stuff we've been doing up to this point this semester? You've accidentally become better at this stuff. How hard would this have been, week 2? Well, impossible if we were doing something exact, but if you just take if you apply a number to this, like just a difficulty number of what we're doing, we just did a lot of crap there. We're like evaluating stuff in different environments and applying, I mean,
That's a
3-star problem. Okay, and Alexis is complaining it was too easy. It's like,
I did it wrong.
oh, well, that's why it was too easy. Like, look, I put a smiley face. But some other people said it was also, you thought it was easier than you figured it should have been, right? There's a lot of stuff we're doing there, right? All right, so let's look at car of that guy. compared to what we look doing, var expression. That dude. Okay, and here we can just cheat off of this. This is what a var expression looks like. Looks like that guy. So we have a variable name, and what do we do with a var expression? We have to resolve that variable, right, in our environment. Now my guess is we probably already wrote that, hopefully. Otherwise, I'm going to write it again. So we have a apply env.
That's what I was confused with.
See, this is what just happened here. So he cost me scrolling earlier, and now wants to prove he's right by saying this is just terrible. All right, so somebody remember that. I assume you'll remember that an environment goes in first. But I probably will not pass it that way because I'm going to forget about this in about 2 seconds when we scroll back down, because I'm old. What was I doing? Forgot what I'm doing right now. This is the problem. It's like the blind leading the blind here. Okay, so apply env, we're going to pass it the environment. We're going to pass it the variable we're looking for. And then this guy should squeeze out the value of it, right? Okay. So if I'm looking at a var expression, what am I going to do? I'm going to call apply env. Do I call it apply env or I call it apply environment? env. All right, and we're going to pass it the current environment, env first, right? This comes first. And then the variable name we're looking for, and that's going to be the car of the cooter. So the cooter of this guy is the list containing that guy, and then the car of that is the A. So this is the catter of parsed expression. So that guy will boil down to. Oh, thank you. I was testing you. Actually, I'm a little disappointed. Annie usually gets that. You usually get my misspellings.
I got the capital E. I just didn't say anything.
Is that an apology?
Yes.
Not accepted. Oh, man. What was I doing? All right. See, I get off topic in my own head. Like it's just multi-threaded. No, we're good. Otherwise, you won't be able to have a homework assignment over the weekend. Are you okay with that? You're okay with not having homework over the weekend? Yeah. You're here to learn. Not here to have fun.
I didn't come here to play school.
Yeah. You came here to learn in school, not play school. When you're paying for it, you might as well get some information out of it. Or figure out how Jigsaw is killing people. Or look at horrible football injuries. I mean, we got this whole list of stuff. But somewhere in there, there's learning. So it's a thing. Oh, Brennan, you'll find this interesting. What's up? So I had to go. So I had to go to this. We had it's like athlete visit day here on campus today. Can you believe there were no athletes for computer science?
No mathletes?
Like, isn't like one of the primary like majors for an incoming athlete? Isn't that computer science?
There's always a couple.
Or is that more of a nerd thing?
More of a business for. I think I'm the lacrosse team. I'm the second computer science major. I know there's one below me.
Oh, from lacrosse.
Yeah.
Oh, what's his name? You mean currently or because
like
Krause?
I was the second.
Justin Krause was in computer science and he was on lacrosse.
Yeah, he graduated before me.
Yeah.
And then Ian Green, who's a sophomore.
Oh, I haven't met him yet.
Yeah.
Oh, is he good or not? Where should my expectations be?
Probably around my expectations.
Well, that could be all over the place. I mean, on Wednesdays, you're like, you know. But I do like when you travel to Cincinnati.
I'm going home for Thanksgiving.
Oh, nice. I'll get you some money. Yeah, Skyline Chili. Everybody should then put in your orders. You should charge a percentage, like a delivery percentage.
Oh,
Are you flying or driving?
yeah.
Oh, so he's got room.
Driving.
If you haven't had Skyline Chili, you got to put in an order for Skyline Chili. It is legit. Okay, so what are we going to do? If we find a var expression, then we're going to apply our environment, which effectively says, give me the value of this variable name. What environment are we applying in? We're applying in the current env, the guy that was passed to apply expression, whatever we're in. And the dude we're looking for is the variable name represented by the catter of parsed expression, which should give me this piece right here. I'm sorry, no, this is my parsed expression in this example. So the catter of that guy would be the car of the cooter. So the cooter is a list containing the A. The car of that is the A. That's the dude we're looking for. All right, so that should give me the value there, which is what we'll then need up here for us to fully test this, right? Close, close. All right, so in this particular example, if we have a let where we're defining we're extending our environment with a variable A and 5, and then executing the body of that A, we should get a final value of what? 5. So if this all works, we're going through all the right pipes, we should get a 5 out of this. And then okay, yep, so we were getting a false before because of, it didn't find the variable in there, but now we, missing a print, badly formed cond. There we go. If it's equivalent, still a badly formed cond. There we go. I'll give you 2 shots at that one, Annie.
Syntax is not my thing.
All right, so yeah, this is the con part of it. Extendenv expects 3 arguments. Oh, did I not pass it the environment? Extendenv, here's the variable name. Here's the apply expression of that guy. Yeah, I need to pass it the environment. And then env, I think I was in the wrong spot. Yeah, here. Yep, there we go. Extendenv takes that 3rd parameter for the environment we're expending. See, that's on you. He's like, oh, you got to pass it first. Why didn't you pass it at all? This one here was for the apply expression, for the value of it. All right, there's our 5. All right, questions about that? So that's not easy stuff, right? But it's far easier for us today than it would have been much earlier in the semester. I mean, now we're building languages. I mean, this was like legit. We defined a variable, expanded our environment that variable lives in, and then executed an expression that lived in this brand new environment. It's a lot of stuff. Okay, and it wasn't overly complicated. All things get a little robust in there, right? There's quite a bit of stuff happening inside of this apply expression, because in order for us to apply the expression, we have to give ourselves an extended environment, and that extended environment takes some understanding. Okay, so let's look at what we got next. So that is, what have we written so far? We have written const expression, diff expression, 0 let and var. Const. Oh, we've done everything but the if? Okay. So, well, let's think about that for an if expression then. So for an if expression, how would we apply this? Because now we got to put ourselves in the shoes of a language designer. Okay, so you're inventing a language. Now we have a preconceived notion of what an if means, right? Is that a true statement for us? We have this preconceived notion. But can we actually implement an if using our preconceived notion in our current language? How does an if work? If we're using the Java version of an if, how does this if work?
Boolean value.
So when this guy is true, what do?
You do the first expression.
I do this. When this guy is false, what do? I do the second expression. All right, so pretty straightforward. That's how ifs historically have worked. Well, now we're going to roll back in time. All right, you're already living there. It's fine. You go back half as far as the rest of us. We're kind of in a similar place. So we're going to go back in time. What if we didn't have this preconceived notion? We're inventing this language for the first time. We've come up with this. We have to create the ability to ask a question, right? Well, what's the weakness of our current language? We don't have there isn't a such thing as a Boolean. So what can we do? In the context of what our language is currently capable of doing, how might you implement an if? You could probably go a couple different routes here, but I think there's a pretty, I think it's probably lends itself to a certain.
Well, we have the zero expression.
Okay. Okay. Well, so 0 returns true when the value I gave it was a 0, or when the value I gave it was a false, right? So we have a way of getting a Boolean there, but for us, it's only testing against 0, right? So might our if expression work if if our expression boils down to 0, that is if 0 question mark or predicate returns a true for it, then we execute the true part of the body. Otherwise, we execute the false. So in the Java world, if we're thinking about this, basically we're asking the question, if whatever you give me is equal to 0, then do this, else do something else. So we're very limited on what question we can ask. Fair enough? Okay. So we're kind of forced into that corner right now. Now we can go some other directions. We can say, well, if whatever you pass me is equal to 5, then let it go. But that's going to kind of require us to remember that the value is just 5. But then again, in our modern languages, we're having to remember this idea of true and false being things, right? So I'm not sure there's a substantial difference there, but I guess it is what it is. But let's go ahead and let's say if this expression boils down to true, and the only way, I mean, that's how we want to go. That's how if statements should work. But right now, the only way we can get a true in our language is through the 0 predicate. I mean, we can't even define a variable and set it equal to true. Can I? Can I write a let and create a variable and set it equal to true? It has to be a const expression with just a number. This is a language that only supports numbers. That's okay. Because what's most important for us is that we understand the limitations of our language. Because as programmers, we're always having to work within the bounds of the limitation of the language we're working in. How many of you have heard the language called Fortran? So one person raises their hand and 2.5 nods. Okay. Well, how well did he teach you about Fortran? Tell me, what did he tell you about Fortran? That it exists? It's old. Okay. Okay. So Fortran it stands for formula translation. Okay. So it's a programming language. Now remember, I've mentioned something that I go back to that thing that all programming languages support the ability to memory, remember stuff, ask questions, repetition, right? So do you suspect Fortran supports all those? If I'm calling it a programming language? Yeah, it does. All right, so, but now there's one thing, and all of you are going to be very upset by this, clearly, which is why none of you are going to program in Fortran. It's actually not often used anymore anyways, but it's not that it's a bad language. But an interesting trivia thing that might pop up at some point, maybe you're on Jeopardy or something like that, and they ask a very computer sciencey question. Do you know the answer? Do you know the question?
Well, I know something that I remember him talking about is that certain variables have to start with a variable name might have to start with something.
Okay, yeah, that's more the syntax than the language. Yeah, I'm not talking about that. So there is something that we've all come to pretty much expect every programming language to have today that Fortran does not have. Some ability, capability that all of our modern programming languages have, that Fortran does not have. And it's something that's very near and dear to our hearts in here. Recursion. Yeah, Fortran does not support recursion. It's kind of an interesting factoid. Must have been that it's too hard to implement, which is why we are going to implement it in our language, right? I mean, the Fortran people couldn't do it, but surely we can. I mean, I can't even remember what function I'm calling it. We're going to implement recursion. We're going to do it. You're going to have to help. And Annie, you're definitely going to have to step up the game, because I'm going to make all sorts of errors in that one. And I mean, she's my go-to person for. I mean, the only reason I'm purposely making these typos is to test Annie. I gotta be careful with her. Aren't you like a boxer? You do like man. Yeah. Like all these people, yeah, all these people are like ninjas around here and stuff like that. Do you know Valerie Locklear is like a 2nd degree black belt? Like legit, not kidding. Yeah.
What?
Taekwondo. Professor Josh Locklear is I think a 1st degree black belt.
I think I knew that.
Yeah, I mean, these people.
Wow.
Yeah.
That's what
Yeah. I don't even wear a belt. I have stretchy pants. Yeah, I got elastic. It's a thing. Yeah.
those are more comfortable.
Well, I also need, depending on time of year, I need expansion. Look, it is what it is. You know, some people do too. You know, they exercise to do for the 6-pack or the 8-pack. I went right for the kegger. Just. It's the first time you've heard that one? Yeah. So easily entertained.
Doesn't take much.
All right, so let's write our if. So we're going to assume that we get a Boolean out of this like we want, you know, like we're used to in our programming languages. But our current language only can give us a Boolean one way. Is the punchline. We can't create them because we don't have the ability of having a Boolean. But we will soon when you write your homework assignment. I'm excited. Good. All right. So let's kick this down. EQV. Oh. I don't like putting those under curly braces. That's because I like at the end you can. I just like that. It's a thing. All right. You guys don't have this level of fun when you're working your homework? You know, smile and joke around and yeah. I actually believe that from you. So we call it an if expression. All right. So if the car parse expression is an if expression, then we're dealing with that jazz. Let me quickly here. I'll just do the. Just return a false here real quick, just so I can give myself a if expression. And so we're going to say if 0. Oh, actually, this would be a good way to really test stuff. If 0 A. Actually, it's just to test it simply. Let's do that first, because otherwise we need a let in order to find the A, right? So if 0, 0, then what are my options here? We can do a, let's just point out numbers. So we'll do 5, otherwise we'll do 10. Simple enough. So it'll boil down to 5 if we have a 0, which in this case we do. Otherwise it'll boil down to 10, so we only have to change this one value here. All right, so let's just look at what that parsed expression looks like here quickly. All right, so here's our if. Here's our test. All right, so we're asking if that guy comes down to true. So this guy is this is an expression, right? So what do we do with expressions? resolve them, we call apply expression. We call apply expression in the current environment. So we're going to ask the question, if this guy boils down to true. And that is the car of the cooter. That's what that guy is in the expression. Because remember, we've already peeled off the A program, so we're actually only looking at this. That's the piece we actually see inside of apply expression. So the car of the cooter of that guy is the expression that is my Boolean test. All right, so we'll ask the question, if apply expression, and then I need to give it the expression itself. So this is the car of the cooter, parsed expression. And then I need to give it the environment in which to apply that expression. If that guy boils down to true, then we're going to do some stuff. What are we going to do? Well, we're going to apply expression this dude, if it was true. And we get to this guy. This is the car of the cooter. This is the car of the cooter. This is the car of the cooter. So apply expression CADDR, parsed expression, ENV. That's what we do if the first thing is true. Otherwise, we call apply expression car of the cooter. That, if it's true, boil down to this guy. If this is true, and we're relying on that being a Boolean expression, right? So we're at this point, we're still not error checking. We're saying, give me something that works. If that's true, do this. Otherwise, do this. All right, so in this case, what should the output of this guy be? A 5. Parse.
Two S's.
Finally, you step up.
Yes. Thank you.
All right, so there's our 5. If I change this guy to anything other than a 0, so let's just throw a 1 in there. Now it should be a 10. There's our 10. All right, so we're starting to get a fairly legitimate programming language here. So now the question is what if we wanted to have the ability, let's get rid of this here for a second. What if we wanted to have the ability to store Boolean expressions? So right now we have this thing called a const expression, which is just a number. What if I also wanted to have a bool expression? So a bool expression, what would a bool expression look like? A const expression was a number. A bool expression would be a, well, probably specifically a Boolean. It's going to be either a true or false, that we're relying on that being built into scheme in that case. But a symbol would give us the ability to do like strings. If we want to have a string expression, right? So that would be that kind of the next thing. Should I give that as homework too?
No.
Okay. So we'll look at just the bool expression. So a bool expression is going to be something that boils down to either true or false. Keep in mind that we already have something called a var expression, and this is something that they've just generically called a num, but we know that's either a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, ... So actually you would write it as 0 to 9 plus. So that's at least 1, 0 to 9. And it does also have that sort of kind of rule. Can't start with a 0, but technically we know what it means, but so whatever. So we know a var expression currently, and I'm sorry, this is not a var, this is a const expression, right? Who dropped the ball on that one? Over and over and over again, I'm testing you, and it's just like, just nothing. Okay, so a const expression we currently support only in numbers. We might change that to a num expression, but right now we'll just say all of our constants are numbers in our languages, so we don't have to change too much in our parser. But now we want to add something in here called a Boolean expression. And what's a Boolean expression? Any expression that boils down to a single value of true or false. So we've accurately described it as either true or false here. So we want to add to our language the ability to support Boolean expressions. All right, so that's things that boil down to true or false. So what does it mean to add a Boolean expression? Well, I'm just going to skirt this down here. So it means you probably need to have something called a Bool expression. Do we need to have something that tests whether something is a Boolean? Maybe a bool like that. This guy takes in an expression, boils down to true if exp is a Boolean and false otherwise. Similar to how 0 question mark currently works. Right? So 0 question mark takes in something and tests that const expression as being a 0 or not 0. Where our bool guy here is going to take in an expression that we would expect. So let's go up here and look at our 0 expression. Our 0 expression is taking in a, we're applying expression this guy in the environment. We're checking to see if it ultimately boils down to 0. What we'll be doing is we'll be applying this expression, this expression in our environment and seeing if it boils down to what? True, or if it boils down to false. How would you implement that? Well, I can use an or, right? So I can say, or apply expression exp equals true. This is kind of pseudocode-y here, so I'm taking you down a path here. Or apply exp is equal to false. What's wrong with this implementation? Or something like that.
Doesn't or support both true and false? Like if both of them were true?
Well, I mean, aren't I calling apply expression and the identical expression both times? So it couldn't be both. It's going to be one or the other. I just sort of kind of gave away the answer. Isn't it inefficient? I mean, aren't I actually doing this move 2 times?
Well, because if it checks true, doesn't it automatically returns false if it's not true, right?
Well, you say it automatically returns false. We're still checking it. How do I avoid making this identical call twice? I could use a let. Why not call it once, store it in a variable, and execute the thing inside the body of the let? All right, so bool expression must implement as a let. So we're going to get smarter. Make sense? So scheme let, not a let in our language. So your implementation for it should create a let, set a variable in there equal to what this dude returns. Then you can check that variable against true and that same variable against false. Make sense? Because if it's either of those, then we would return a true that this guy is a Boolean. Because that's what bool returns, right? So you're going to have to add these abilities to your parser as well as the apply expression. So for Monday, add the ability to parse bool expressions and then the bool predicate to your parser, and then also build in those abilities to your apply expression. Make sense? Okay. Similarly, I mean, you won't have to add this ability. It's just going to be a secondary thing. Now, var expressions will be able to hold bools. Right? We'll be able to, let expressions will be able to support the addition of a bool. Therefore, our var expressions will be able to resolve to a bool. And you won't have to do anything special for that, because already our let expressions say this variable name equals this expression. And now we'll have a way of having expressions that are Booleans. All right. See everybody on Monday, and I'll post. Is it easiest for me just to post the entire screen again for the code, so you just have that as a starting point? Is that way you don't have to pick and choose? So you're going to get duplicated code here, but I'll just give you my current version of this guy, even though it's just a wall of code.
I won't be here on Monday. I got
Okay.
a doctor's appointment.
Okay.
And it's at Mayo Clinic, and they might keep me overnight. I'm
That's
not
fine.
sure.
So
Maybe
yeah,
later.
if we do a quiz, just remind me and I'll excuse you
Okay.
from it.
And then on Tuesday morning, I might not be here either because they might keep me.